Thanks, Michelle. So it's my pleasure to introduce our speaker today, Dr. John Ziemer, who is the Concept Innovation Methods Chief at the JPL Innovation Foundry. He did his undergrad work at the University of Michigan and his graduate studies at Princeton University, specializing in plasma science and electric propulsion. He's the recipient of a number of awards, and just to name a few, the JPL Mariner Award, the JPL Explorer Award, and the JPL Individual Outstanding Achievement Award. And today he's going to talk to us about exploring mission concepts with the JPL Innovation Foundry A-Team.
All right, thanks, John. Yeah, that title is a little bit of a mouthful. Concept Innovation Methods Chief. The JPL Innovation Foundry has been around for a few years. I'm not going to really talk about that today, but it's an organization within JPL to help develop concepts all the way from just the bare idea all the way through a proposal to NASA or to another institution. So I'll be talking about the JPL Foundry A-Team, which is a new team. It's been around for about 2 years now that focuses on the very early part of the concept development. Okay, so I warned Andrea about this next slide. So I have a question. I'm a principal investigator for an upcoming competitive solicitation. I would like to explore the alternative mission concepts that achieve my science goals. John Brophy, I am developing a new piece of technology and I need to identify system-level applications, mission concepts, and potential sponsors to justify additional development. Brent Sherwood, there is an opportunity on the horizon for my program office and I need new ideas that can actually work. Where do I need to invest to make them possible? These are literally questions people have come to us in the last 2 years to answer. And so these are the kind of things that the A-Team works on, just in general. And if I were to give you my thick elevator speech, the A-Team efficiently explores the science, implementation, and programmatic trade space in early concept formulation. Small facilitated groups of experts generate innovative ideas, quantitatively assess feasibility, and discover key sensitivities in the trade space through collaborative analysis and use of advanced methods and tools. That's pretty thick. I'll go into a lot more detail on each of those words. But up there you see a picture of left field. That's where we get to practice our craft. It has wall-to-wall whiteboards, movable, completely configurable depending on the study. We rearrange it the way we need to depending on what the topics are and depending on who's coming in and how many people and what the goal of the session is. And that's our dedicated facility. So what does the A-Team do? Well, I tell people my job is really to manage a conversation. And so it's a conversation that is at this early concept formulation, a combination of the science, the engineering, and the programmatics. Okay, the science, the question you want to answer, the engineering, the implementation, the technology you have to answer it, and then the programmatics. How are you going to actually fund that? What do you need to do now so that 2 years from now you're ready to propose? Those kind of questions are the fundamental things that we have our conversations about. And in the end, we hope that through these conversations, we actually generate what I call a spark. Something in there that it's more than just what you came in with, but it's something that's an additional, now we've got either a better understanding of the problem, more concise statement, or more data, more analysis tools to know our next direction, our next step. We're not, in fact, a lot of the times, and most of the times, our studies don't provide the answer. Most of our studies give you an idea of what the answer could be better. It gives you an idea of what you need to do next to find out what the answer is. It gives you an idea of what other people might be doing or where you sit in the grand scheme of things, and how the program office or how the funders might view you and what directions you might need to take your concept to make sure it gets that next infusion of funding to take the next step. Okay, so if we say that there's a process to the A-Team, it contains these kind of words: research, question, create, provoke, test, explore, narrate, stretch, evaluate, discover, reveal, and materialize. Those are words that they almost go in order with our process, but they sort of, that's the feeling that you get when you go through different steps, different parts of an A-Team study. Okay, so the agenda for the rest of my talk, I'm going to go into a little bit more detail about what is it. I'm also going to talk and put it in the framework of something we've called the concept maturity level. A lot of times we have a person or a team that comes together and they think they're ready to propose, but in reality they've got a lot of work to do. And so what we like to do is put them sort of on a scale of maturity. And that scale helps us define what they need to do now, what they've got now, what they need to do next. And I'll talk about the things in that context. I'll also talk a little bit more detail about what we do, how we work, who's involved, and why you'd use it. Some discussion of study methods and examples, and then I'll touch a little bit more on how we're going to improve. Again, we've only been around for about 2 years. We've done about 70 studies during those 2 years. The first year was about 25 studies, and this year has, then the following year was about 45 studies, or 35 studies rather. Did I do that math right? Anyway, total of about 70. Right now we're doing about a study a week is about the pace that we're at right now. Okay, so here's this scale that we've called the concept maturity level. I did not develop this. This is something that some folks in the Foundry before I got there worked on. But it's a very useful tool for understanding sort of where you're at in your concept. So it starts all the way at CML 1, which is literally the idea on the back of a napkin. Okay, so or a sticky note, or a white paper, or something that's very rudimentary. Sort of, I've got this idea. And here's the key nugget of it. Here's the reason why it's a special idea. Okay, that's the CML1. CML2, you start to talk about feasibility. Can you really do that? Does it violate any laws of physics? Does it violate any programmatic rules? Are you really going to be able to find the funding and everything like that? Or are you just repeating what somebody else has done and so therefore no one's going to fund it? Questions of feasibility. Can you get there? Can you do it in the time that you have? Is it an event driven? All sorts of questions go into feasibility. Then the trade space. We try to broaden out the idea and understand what are the options to accomplish this idea. Which ways can we do it? Do we need new technology? Does new technology help? Are there different opportunities or different partnerships that we can bring in to help your idea mature or get it to the next step? All those things end up with the trade space. It covers the science trade space, the engineering trade space, and the programmatic trade space. And so it's a lot of different options to consider. Then we that's where the A team exists, and then we hand over to, some people might have heard of Team X. That's another thing that's been around in JPL since the 90s. The Team X focuses on a point design. There you're actually starting to select components. We're going to use this antenna. We're going to use this solar panel. We're going to use this spectrometer. And you start to design the entire mission around much more detail. And then at CML5, you're ready to propose. That's basically the first time that you would actually get your concept together in a fairly large 100-page, 200-page document ready to go to our sponsor to have them go through a competitive selection. If you get selected, a lot of times the next step that you have to take is still competitive. There might be one or more proposals that were selected at that point, and there's still a down select afterwards, or NASA still wants you to ensure that you're progressing along before they give you the full selection and full invitation. So you go to CML6. CML7 is basically equivalent to a requirements review. You've got all your requirements established. And then CML8 is something like a PDR. And that's where the Innovation Foundry stops. There's another organization. Preliminary Design Review. That's in sort of project management, engineers. That's sort of the first time you get together and have a design that you believe will meet your requirements. And then the next thing is called the Critical Design Review, where you prove it. Right? So the preliminary design review is sort of where formulation ends. And that's the real boundary of where the Foundry behaves and exists. Nope. Team X, so there's a slight boundary here. Sometimes Team X goes back to CML3, sometimes the A team crosses over into CML4. So it's sort of fuzzy around here. But yeah, Team X, if you were to ask me if somebody came in with an idea and said, I need to get a point design, I'd send them right to Team X. And if they wanted to get it ready for a proposal, they can still go to Team X. Team X can help with a lot there. Once you get to higher CMLs, then you have a project team of 20, 30 people working on the detailed description of things, and Team X sort of can't quite keep up with that. So one of the things we notice is that around sort of the middle of that area, there's a lot of churn. People will come in with what they consider to be a feasible concept. Then they go through a trade space exploration and find, wait a minute, the other option is there, but that's not really feasible. What do we need to do to make it feasible? Or they even get to a point design and realize the estimates that I had back when I first started aren't even close. Wow, I've blown my mass budget. I need to go back. And so we see, I'm not a big fan of animations, but this is sort of fun. You see a lot of churn through there. And so the A team was originally designed to basically help that churn early on, because without it, 2 years ago, there wasn't anything like that. Basically, people still did this work. It's not as if this work didn't go on. But there wasn't a practice established. There were people established who were good at it or not good at it. And you either got those people and you were lucky, or you didn't, and you didn't really have a place to start. And so the A-Team was set up to basically have the same kind of service orientation as Team X did, where anybody can come in and use this if they would like to, or not. They don't have to. There's no regulation or rule that says you have to go through the A-Team at JPL to get your concept matured. So it's a service. So we have to be good. If we're not good, no one will come and use us. OK, so if we look at sort of how an idea starts and where the A-Team sort of fits in, you have the CML one, you have the salient kernel documented. CML2, the fundamental feasibility of one or more approaches is validated quantitatively. This is where we really want to apply some analysis tools at the very beginning. It's very important. Then we broaden out those ideas, and we open up the trade space, we frame the key question, analyze drivers, derive and assess the partials. We try to look at, again, at this point, we're not coming up with the optimum solution. What we're trying to understand is if we start to vary this, or choose this instrument over that instrument, or choose this propulsion system over that propulsion system, how does that affect the rest of the system? All of our space missions are very integrated, very tightly thing. One change, one notion changes everything else. And so understanding what we call the partial, when you change one thing, what happens to everything else, is part of what exploring that trade space is. And then we start to neck down, and we start to specify our value framework. What's important to us? Mass and power and everything like that on the flight system is usually typical, but there's other things. Cost, timeliness, the implementation of technology or partnerships. And then we prioritize promising directions. And so we try to get down, by the time you come out of an A-Team study, we try to get down to something like a few handful of options if you go all the way through to CML3. Now, not all of our studies go all the way to CML3. In fact, some of our studies start, and all they want to do is generate new ideas. Or they come in and they say, I've got an idea, just tell me if it's feasible. Or other people come in and say, I've got this feasible idea, I know it is, but I'm trying to figure out what's the right flight system that I want to put along with it. Is it going to use chemical propulsion, electric propulsion? Am I going to need a 4-meter dish, or can I get away with a 1-meter dish to pull, those kind of questions. And so then it all depends on sort of where you're at, and we do an assessment of sort of what your concept maturity is first before we start to plan out what your individual study is. And we tailor every study to the individual's needs. So if we were to, the next thing I'm going to do is describe a process. It basically starts with a person, an external PI, an internal PI, the chief scientist at JPL, the chief technologist at JPL, the director, the program director, a program manager, a line manager, a project or task manager, or even the Foundry itself can all initiate a study. Okay, so basically, almost a lot of these folks exist at JPL. Again, we've had folks from all the way from Dr. Lacci all the way down to someone who has a 100K study, and they're trying to get part of that study answered for NIAC, and they come to the A-Team. So we have a wide variety of customers come through our door asking for different things to do. Okay, basically they start with an idea or question. And then we say, OK, that goes into what we call our study net. So we start to, because some people come in and they don't even have funding to make a discovery or take their idea anywhere. So it goes into this network of different program offices who have funding to do those kind of things, or maybe they already come in line and they've already convinced a program office that they should fund one of these A-Team studies. But that's where we start. We basically try to build that network of the combination of the Foundry, that's us, the program officers who can fund the study, the Section 312, which in JPL is a group of people who specialize in formulation. So we get sort of line them up with some folks there. And then we make sure that the program office is OK. They're the ones who are actually going to fund our studies. So we're not a service for free at JPL. At JPL, you have to use basically your project money or your research money or some funding source within JPL to pay for one of our studies. The next thing we do is we start to bring a team together. We start to staff the study. We start to understand what the needs are for the study. Next thing after that, we put it in, we basically make sure we have a concrete study goal. We have someone from the client and the client lead, someone who's actually going to drive the study in terms of what they really want. The time frame for the study, do they need the results tomorrow, or do they need the results 2 months from now? What's the driving force behind the study time frame? And then we give a study lead. A study lead is someone who's very familiar with the A-Team practices, who's very familiar with our tools, our processes, the other staff members who are going to be a part of that. We supply that study lead to the client lead. The next thing, it goes into, once we actually see this, we start to see that there's a concrete study. There's going to be a real thing here. So many times people come through our door asking, I'd like to do a study about this, and we try to help them get started, we try to help them go, but something like probably a third of the time it doesn't work out. But once we get past this point, we sort of feel like, okay, it's really going to happen. So we start to dedicate some funding to actually planning out the staff, the roles, the budget, setting the objectives for the study, the products, and the schedule. So getting much more concrete and detailed. We do a lot of planning work up ahead of a study. Usually it takes at least a week. If the shortest time that we can turn around things has been a record is probably 2 days. But for the most part, we like to have at least a week of time for us to get together people. Even a couple weeks is better. Because most of the people that we want to get involved with our studies are very busy, and trying to get their time is very challenging. So it is a lot of logistics that go along with these first couple weeks of the study. Then we have a meeting where we get everybody together, the people who are paying for it, the people who want the study, the people who are going to lead the study, and us as regulators. And we have what we call a planning meeting or a green light meeting. Everybody gets together, we all agree on the scope of the study, we all believe that this is what's the right plan, it's going to work, and then we kick it off. And so the study itself has people from the formulation section at JPL and technical divisions. So we actually pull from the resources within JPL and sometimes outside of JPL for the members of that study. When we say a team, it's not a team. It's at least 5 or 6 people that have gone through the A-team process before, but then the rest of the team can be completely configured to whatever the study needs. In fact, a lot of times the client will bring people with them to the study, and we accommodate that. So we have to train some people when they get in sort of how to behave or how to act inside of our studies, and that's fine. We recognize that we deal with that every study. And so like I said, after that, the study can be, we basically make sure we've got the go-ahead to proceed from the people who fund the study. And then if they want to start at CML1 idea generation, we do that. We pump out again, and we ask again, do we want to proceed to the next level? We do the CML2 study, feasibility, and then we can do the CML3 study afterwards. So we sort of take those moments and sort of check in with the program office, check in with the client, and make sure everything's going okay before we take the next step.
Is this a fixed team?
No. It changes. There might be 1 or 2 people who are on, who are on a number of studies, but other than that, it's configured for each study. Each study is a different group of people.
So you have this pool of people who are sitting around waiting for your phone call?
Not really. They're all very busy people. In fact, we want busy people. We don't want people who are just sitting around not doing anything. We pay for the salaries of a day a week of what we call the core team, and I'll go into a little bit more of that in detail, because there are times when we need to pull people really quickly. So we do have some funding to give some people some work in the meantime, and if we need to take them away from that, then we can take them away really quickly and and they can go back to their day job. But otherwise, yeah, we have to find time from people's regular jobs to come and help us with our studies. Okay, and then sometimes the path is completely different. I don't know how else to say that, but sometimes we can just jump right into a feasibility study, or just jump right into a trade study, or only do one of the things, and there's all different paths to do, and like I said, it's all things. Now, what we do in our studies is we have a number of sessions. Okay, so any study in particular can have just one time everybody gets together and meets together, or 2 or 3 or 4. Sometimes the meetings are with the whole team, and other times it's just with a subset of the team. And so we design all of those sessions ahead of time. All right, so we know how much the study is going to cost, we know what the details are, and specifically what the objectives of each session are. When I say that my job is to manage the conversation, it's also to make sure that people who, and all of us want to, talk about everything under the sun. We can't. We don't have the time or funding to do that kind of thing. We have to keep it very focused. Each meeting, each time has a very specific objective, has a very limited amount of time to achieve that objective. And so we have to keep the agenda, what we call the conversation map, very tight for each of those meetings. And here are the different things that we could do, objectives that we could have during sessions. Not all of these. You can grab 1 or more of these during any session of the A-team. So describing background research, where we have people come up and say what they know, so they give the knowledge to the rest of the group. Reviewing and refining science objectives, including traceability. Traceability is very important to us, understanding where that requirement came from and why. Brainstorming new ideas, organizing and prioritizing ideas, defining the feasibility and trade space boundaries, and figuring out what the figures of merit are. Creating science cases or seeds and implementation cases or prototypes to explore the trade space. We have this sort of thing we like to call rapid prototyping. It's not in the conventional sense of 3D printing or something like that, although we do have 3D printers. But The idea is that you don't have to get the concept right the first time you try it. Okay? Take away that barrier. So many JPLers, so many engineers feel like the first time that they're going to put an idea down and be concrete, it has to be the right answer. We try to get away from that because that takes a lot of time and it actually is kind of anti-productive by the time you're done with it. We really want people to put down their first ideas, and if it's wrong, fine, we'll figure it out and we'll fix it. Okay? So it's important for us to do these sort of prototypes of different concepts that would meet the implementation requirements. We do real-time analysis to answer targeted questions or trades. So we have a lot of new tools that are meant to, in real time, do trades between subsystems or trades between different instruments or look up things. We have databases available. We have tools that are able to put different scenarios together. We assign tasks that will occur between sessions. Some of our things require more analysis than we can do in real time. If you need a thermal analysis, you're not going to be able to have the person, the engineer, sit there in the thing and build up a 3D CAD model and actually do all the boundary conditions and everything else you'd need to make an analysis. So we find out what those analysis tasks are, and we go and have them do those between the sessions. And then they'll report back at another session. So we're reviewing the results from the offline tasks. And then synthesizing a small number of concepts that should go forward and more in depth, so we actually do some down select, and developing a strategic map based on the recommendations for the concept's development path. So this is an important product of an A-team study. For every study we do, we have a strategic map at the end of it, which is a roadmap for every concept NASA ever develops. If you look at almost every concept I can think of has been probably canceled at least 3 times in its lifetime before it actually got to fly at JPL. And so navigating the space, the decade that it takes for your idea to actually turn into a mission concept is very challenging. And so understanding when opportunities are there, when you can grab them, who you should talk to, who you need to get in line to help you, who you should partner with, all of those questions are very important questions to actually getting your idea from just an idea into a real flying mission. And so we try to help you navigate that whole space with a strategic map. Okay, so the key aspect to innovation at JPL, the key aspect to the A-team at JPL is people. What we really try to do is have a blend of experience with our A-team studies. So we intentionally staff our studies as much as we can with people basically that form different roles at JPL and outside of JPL. So scientists, mission architects, program managers, technology developers, instrument and flight system engineers. And then on top of that, we like to have different experience levels. We like to have people with formulation experience so they know how to behave in this sort of creative, crazy environment. Or flight project experience people who are like, no, this is the way we do it, and we're going to do it this way. Right? And experienced JPLers, people who have been on the lab for 20 or more years, and very early career hires. We like to have them all together in the same room. Okay? Now, specifically, we've had a few questions about what is the study made up of? How does the study behave? Well, in every study, there's only 6 roles that every study will have these 6 roles. And we call it the A-frame because there's 2 parts of it. There's a methods part of it and a technical part of it. So there's a facilitator, a study lead, and an assistant study lead on the methods side. And then on the technical side, we have an architect, a lead systems engineer, and an integration engineer. What we've noticed is that most of the time when people put together their concept team, they actually are missing most of the methods folks. In other words, they get a bunch of technical folks together and assume or hope or push for them to do all of the other stuff, all the sort of soft skills. And so some of the things that we've noticed in the A-team is that when we bring and we train our methods folks to be very good at managing these conversations and planning these activities and doing the background research and doing some other things to make sure we're successful in our studies, those are the most important aspects of what differentiates the A-team from other ways of doing these early concept studies. The technical expertise at JPL is deep and widely available, right? The methods is not. And so we actually spend more time trying to find methods folks than we do necessarily technical folks, although sometimes it's challenging to find the technical folks as well. Then, of course, we bring in a slew of subject matter experts. Once we understand what the study is about, we start to bring in folks that have that kind of specific expertise. If we know we're going to be working on a CubeSat solution, then we'll bring in folks who know everything about CubeSats. If we're going to be working on a very challenging communication problem, then we'll bring in a communications expert. If we're going to be working on a very challenging propulsion aspect, we'll do that. Or a scientist or a team of scientists that have to do, that understand a specific instrument, like a drill or a spectrometer, we'll bring in experts in that area. So anytime that we understand what the main challenge, what the main thread of the study is going to be, we find the subject matter experts that are along those lines as well. And a lot of times the client may also bring in members from their own concept team. That happens often. And so how do we fill this? Well, what we found in our first year is that finding these folks was a challenge, but doable. Finding these folks was almost impossible, because those soft skills of people of the study leadership and the facilitation and the assistant study lead, all of those things were very, people don't necessarily get trained for them, they're not hired for them at JPL, and so finding those soft skills was actually much more of a challenge than finding the technical skills. And so what we started to realize is that on both sides here, there's sort of a mentorship where we can bring in people at the bottom of the A-frame and sort of train them to take on higher and higher roles. And so there's a lot of training that we found. There's natural training at JPL for these technical roles. But what we found is we had to create our own training for these methods roles as people go up. And so we created what we call the A-Team Core. It's a member of about 12 people that actually have these skills and are trained in the expertise of facilitation, study leadership, knowledge capture, our tools and infrastructure. Also, they have their technical aspects of whether they're a flight systems or an architect. Their deal with the configuration, how we pull together the mission and what it looks like, mission design itself, trajectory optimization, instruments, remote sensing, and Situ and radar, technology, cost, and risk. So I can pull on any given study, I can pull from those 12 people. And I usually grab 2 or 3 of those people to be part of the study, either on the methods side or the technical side of the study. And I fill in the others as I need them. Now, not every study needs all 6 of those people. They need all those 6 of those roles, but sometimes people can do double duty. So if we go back, sometimes you can have a facilitator be the architect also, or a study lead be the lead systems engineer. They can do double duty. But oftentimes that leads to confusion and other things like that. We try not to do that, but sometimes the scope of the study just doesn't demand 6 people. It always demands 6 roles. So these core team members actually are pretty privileged. They have a Google Day. They actually get a day a week to improve their craft, to work on their studies, to work on tools, to work on helping the A-Team process, improve, and practice. And during that time, if we have a study instead, then they go work on the study. But once they're done with that, then they go back to their day-a-week job. So they're very flexible in terms of what we can do. And we found that we need that in order to pull this 1 study a week off. It was fine when we were doing 1 study a month. We didn't need that kind of back up. But once we were doing 1 study a week, we had to have it that way. Otherwise, we just could not staff the studies. These are names. I could tell you the names of all these people, yeah. Yeah. OK. Our methods. So what do we do with the different CMLs? Well, CML1 is that idea generation. So it's capturing ideas and linking associated ideas. That's really important. Like I said, back to that traceability idea. We really like to know where the idea came from and how they're associated with each other. Because during the feasibility, we start to test those links. We start to see, and during the train space, we start to understand what the derivative is of those 2 links, if you will, what the partial is between why are those 2 things connected. So we do a lot of research, and we bring in previous studies at CML1. So we want to make sure that there's not something repeated or something that we can learn from other studies that we've already done. And those include Team X studies, those include proposals JPL has written, those include other mission studies JPL has done before, or outside sources have done. We start to bring analysis tools here to assess feasibility, and we start to find these figures of merit and thresholds in a space. And then at CML3, we start to really build the seed concepts and concept architectures and do some more analysis. And like I mentioned before, sort of these rapid prototyping of concepts.
You just mentioned passing outside sources.
Yeah.
JPL's huge weakness has always been not invented here.
Right. Right.
Do you do anything proactively on that subject, or do you just hope it's not, hope you don't fall into that trap?
No, we try to be proactive, but you know, we feel a lot of pushback once people are skeptical a lot of times of what other people. But let's be honest, there's expertise outside of JPL that's even better in some areas than what JPL has to offer. Now, we don't do that very regularly, I'll be honest with you. We leave it at the discretion of the client about whether or not we bring in people from outside, but we'll try to suggest it. Oh yeah, we definitely do that. When we do our research work, then we definitely do literature search. We're looking for, when we do a mission on Titan, we don't want to know just what JPL wants to do a Titan mission. We look at what everybody has proposed or studied for a Titan mission. Yeah. Okay, so the tools that we have available, and we're working on our tools. We didn't really start with any tools to begin with. So we've got something we call the A language that's about how we capture knowledge. We found out that actually as the session's progressing, we don't want people who are actually participating in the study taking notes. That distracts them from what's going on. So we actually have people just dedicated to doing knowledge capture during our studies. And they have a quick way of doing that now called the A language, where multiple people can contribute to a PDF document that basically gets assigned and grouped and organized. So basically, somebody's literally working on the whiteboard while somebody else is sort of mapping what's happening in that. In fact, we even have tools that record what happens on the whiteboard if we need them. Or we can bring in images or web links or documents or whatever we need to into this sort of compact PDF. We use a wiki for basically capturing our study information. Every study gets its own wiki space and gets the access control to whoever the participants are. After the study's done, they get the wiki. They can do it, they can keep using it, they can not use it. It's there for them to use. We have a lot of IT software building up now and capture hardware, pictures of the whiteboards, that kind of thing. We're working on science traceability thresholds and value tools. So we have these science traceability diagrams. Those are an interesting thing that helps us understand sort of what the root needs are and the various different ways you can achieve the science. We've got different tools that help evaluate the science value. That's a tricky one because it's all relative, right? But oftentimes, almost always, a PI will come into an A-team study with more science than we can achieve for the amount of funding that we're going to be able to get for that mission. And so we have to be able to include some kind of value, what's more important than others, and maybe how challenging something is versus another. Then we have a lot of tools for gearing up what the mission, flight system, and payload design will be. We have this new tool we're working on called 5-minute mission design. Right now, JPL is known for its trajectory optimization to different planets. And a lot of the time, those kind of optimizations would literally take weeks. You'd come in with a set of parameters, you give it to the trajectory optimization guys. A week later, they'd come back with results, and you say, wait a minute, I like this space, but please tweak this number and everything like that. A week later, you come back. That doesn't work for an A-team study. In fact, if we could, we'd do it in real time, right in the study session. And so we've got a guy who's working on massively parallelizing the trajectory optimization code. So basically, we can put it to the cloud, and instead of 1 week, we can get an answer in 5 minutes. And so literally, you can do a trajectory optimization, search for something, get a trajectory. Here's your launch date. Here's your arrival date. Here's the delta V requirement. And you can, oh, wait a minute, let me change that parameter. I think actually my flight system is going to be 50 kilograms less. Bam, new solution 5 minutes later. And so right now, it doesn't do all the delta V's like gravity assist, so it doesn't have all those permutations in it. But otherwise, it has sort of full fidelity for a chemical propulsion system that can go to any planet. We're working on adding the gravity assist, and we're working on adding low thrust EP systems. So that's coming. Again, we've only been in business for a couple years, so we still got a lot more work to do. We have these things called baseball cards for flight systems. So we have the full detail of flight systems that both JPL have shown, and now we're working on something like 180 different flight missions for both Europe, all of the US, and Goddard, and NASA. So we're trying to build up these sort of database of flight systems. And we have physics-based instrument sizing tools. So if you know the wavelength range of your spectrometer and you know the resolution you need, we can help size what that instrument looks like based on previous spectrometers, which then goes into some of our cost tools that tell us whether or not how much that instrument could cost. And so we always worry about cost, always worry about cost. It's almost effectively in every trade space, one of the axes is going to be cost. And so we have a lot of work on cost, complexity, and risk in our cost tools. And if anybody wants like a little demonstration, I can even show you. If you come up with a mission idea, I can roughly tell you how much it costs. OK. So our facility that we have is called Left Field. It's, like I said, it's wall-to-wall whiteboards. We also have an connecting outside space. It's nice for most of the part in California. In fact, it's under a little bit of a cover, so even if it's raining, we can be out there. The space is entirely configurable. We can move tables around. We can have small work tables. We can have one big, large table. We have a number of different things to help us construct ideas physically, like putting together various cardboard models or foam cutters to build different things. And a lot of times we'll split up. The conversation will start with the full team there, but then we'll split up into smaller groups and have some small sub-conversations on the side. So I did a fun exercise. I did a Wordle of the last 2 years for the A-team, and this is what came up. So you can see the sort of, this is a Wordle of our sort of end-of-the-year report from this year. So you can see that we do a number of studies, of course. Science is a big part of our studies. We're working on a lot of tools and process, and this sort of gives a neat view of sort of what we've been working on the last year. Now, if you break down these studies into types, we generally have about 6 different types. We have an idea generation type. I've been saying this before, a feasibility assessment, an architecture trade space exploration study. And then we have a side, sort of a orthogonal view of it is your study really about science traceability? Is it really about having a technology impact, or is it really about strategic investments opportunities? So in the science traceability, we try to link science questions to goals, objective measurements, and instruments, including assessing relative science value and ranking. So it's from technology and fusion usually has two aspects to it. Folks that are developing the technology that they want to push into missions, and missions that are saying, we need this technology in order to function. So it's a pull function. So we work with both of those teams. We can work with a technologist that says, here's my technology. What's it good for, after all? What can I really point to and say, this is going to be a breakthrough mission for my technology? Or we can have a program office saying, I really want to go do this mission on Titan. What technologies do I need to make sure that I can do my mission? I've got an opportunity 3 years from now. What should I be working on right now so that I can prove to the world that I can be ready to go to Titan? So those are technology push and pull studies, and we do both. We're also working on the Office of the Chief Scientist at JPL and the Office of the Chief Technologist at JPL are both very interested in sort of hearing the generic outcomes of the studies, because as they plan their roadmaps and see what JPL wants to invest in, they want to hear from these early concept studies where really this is like the only chance technology really has a chance to get infused. If you're up at CML4 and you're already at a point design, that's probably the very last time you can get a new technology into the mission design. And so if you're not in this sort of early technology trade space, it's really hard to get in there afterwards. It has to be a major problem that the projects come up with that they have no other solution, and then they'll probably invest in new technology. But if you're proposing even a new technology, so if your technology is at TRL 6, by the time you propose, it's very unlikely it's going to get funded. It's deemed as too risky. So you really do have to know well ahead of time if you're going to have a new technology into your concept. And so we want to have that feedback process with our folks who help decide what JPL is going to invest in next. So they know sort of what's coming, what people are looking into, what people want. And so they're interested in getting that feedback as well. And then sometimes the program offices have a pure strategic question. For example, one of our studies was epoxy, this mission that was called Deep Impact first, that hit an asteroid and then looked at the plume that came off after that. After that mission was done, it's still a working spacecraft with a couple different telescopes. What could it do afterwards? Well, they went into this mission called epoxy, where they looked at a bunch of different things, actually, with their telescopes. The funding ran up for that. Then they came back, and they actually did an A-team study saying, what should we propose to NASA to do next with epoxy? And so that was a purely strategic thing, where we actually helped them develop a presentation to take to NASA to suggest different things they could do with the epoxy spacecraft. So that's the kind of strategic investment or opportunity kind of study that we use. So here's actually these are just names of studies. If you're interested, I could talk about afterwards what each of these things were about. But as far as idea generation, we've looked at Mars caves, dwelling in Mars caves, small sats for supporting human spaceflight. For a feasibility, we've done things like public outreach. We actually had Insight before they were selected come to us and say, we need a public outreach plan. Here are the things we're thinking about. Are these feasible? Will they fit within our budget? Will people be really interested in looking at them? Planetary science from atmospheric balloons. And then on the architecture trade space, we have fewer of these studies. SWORD was one, low-cost landers, where they actually got into technical detail of the trade space exploration. Here's some science traceability ones, a thing on sea level rise initiative using CubeSats for Earth science missions. Technology infusion, we were looking at what the benefits are for high-performance space computing and in-space propulsion for Mars sample return. And then strategic, that epoxy follow-on mission I was talking about, and then exploring future spacecraft and science missions, where sort of NASA as a strategic level was looking at where the directions were going for various spacecraft and science missions. So if you break down, we've done, like I said, we've done about 60 studies. If you look at the very first 50 of them, these are the statistics. So 40 of our 50 studies included some CML1, some kind of idea brainstorming. So a grand majority of them have some kind of a brainstorming aspect to them, an idea generation. 38 of our 50 studies included some feasibility assessment. That's the majority of what we do. Most of the time what we do, our studies end at CML2. Over half of our studies end at CML2. So the person says either, no, sorry, it's not feasible. That's rare. Or here's your feasibility options. Why don't you go explore those a little bit more before you come back and talk about the one that we want to do a trade space exploration on. So there's a lot of gap in between sometimes the CML2 and the CML3 study. So 15 of our 50 studies include CML3, and of course, that's where we stop. So if you get to CML3, then you stop there. Out of those 15, about 5 of those went on to TMEX. And so you can sort of see the natural funneling down of how many ideas we start with versus how many get to the next step. Because each of those steps cost a little bit more funding to even get an investigation or a study going. On science traceability, out of the 50 studies, 9 have really focused on science traceability, 13 have focused on technology, and 13 have been strategic. So you can see those don't add up to 50. So there have basically been other things that we've worked on, or some aspect of, little aspect of all those three. And now I'm going to show you some of the products that we've produced from some of these studies. So for example, one of these things, and I'm sorry if they look blurry, it's intentional. Some of these folks were okay with their images being shared, but not necessarily the exact numbers, so they're sort of low resolution on purpose. Where we looked at various different things about what power should you demonstrate in an electric propulsion demonstration thing. What's the right power number and why? How do you justify that? What missions could you do with that kind of a system? And then what are the component technologies that have to go along with that? What's the strategic map forward of how you'd suggest on how to fund that? This is a presentation, again, that went to NASA headquarters. Here's another one. This is called the Sears Solar System Architecture. So this is from a NIAC study. NIAC is NASA's innovative advanced concepts. It's basically, if your idea is supposed to happen within 10 years, it's not a NIAC idea. It's got to be past some idea that's way out there, right? Phase 1 folks get about 100K. That's a competitive selection across the whole US. It doesn't have to just be NASA. It can be academic institutions too. There's only about 20 or 30 of those selected each year. They get 100K to basically develop their concept and hope to get a phase 2 where they can do a little bit more work on it. And so here's a configuration idea we had for a solar sail that was actually going to go to the heliopause. It turns out that if you use a solar sail to get to the heliopause, you can actually get there in half the time that Voyager did. And so you can get a whole slew of instruments that are actually designed to look at that boundary, the heliopause, the boundary there. You know, the Voyager instruments are great, but they're not quite exactly what you'd want to investigate that. And so this mission was trying to advocate for a solar sail. And here's the deployment of the solar sail for this probe afterwards with the magnetic field measurement booms deployed as well. A lot of times our studies, I would call them science-driven processes, right? So we start here at the science. Let's say we come up with you say you want to go to Titan. Well, we come up with some ideas for how you might do that under the Discovery program or the New Frontiers program. We develop these prototypes, options to investigate the trade space. They're sort of these floating points we put in the trade space, and we sort of watch how they move to sort of understand the sensitivities in the trade space. They're really designed to push the limit on the first loop, and then on the second loop we go through, we try to focus them down and get them to be more optimal. So that's what I was talking about before, this rapid prototyping, where we don't worry so much. Sometimes intentionally we take ideas that aren't really going to be our final solution just to see how that system looks, just to understand how that system would get built. And then we refine to different cases. So there's sort of this iterative loop between mission design and flight system payload analysis. And then once we're done with that, we have an idea. We go all the way back and start at the science again. Did it achieve the science objectives? How do we have to modify the science objectives? And we start the whole process over again. Hopefully we get to go through that loop a couple times. So here's what a trade space kind of looks like. This is a trade space for a Jupiter type mission. So we're asking, is it a flyby or an orbiter at the root? Is it going to be a chemical versus SEP? Is it going to be a nuclear powered or solar powered? Is it going to be there for very long or be very short? One versus many, jet versus Juno bus analogy. And then we say basically on all of these things we have to evaluate its instrument coverage, its data return and power budget, its radiation dosage because Jupiter's a bad place for that, the thermal design, and what the contributed hardware would be. So that's our trade space that we operate in for that particular study. Mars CubeSats. These are some examples of some ideas we came up with, and then our configuration engineer came up with some different ways of stacking together parts. So we've actually got a library now of CubeSat parts that if we have a CubeSat study, we can start to build those things up pretty fast. In fact, 3D print them if you want them. You can have a 3U CubeSat on your desk after the study if you want. This is another one where we basically said we were looking at Mars missions with a mothership, daughtership CubeSat kind of configuration. We were looking at what exists now to facilitate that, what would need to be developed on the CubeSat side of things. And then also, basically, if you were going to do this as a standalone CubeSat, maybe a 6U or something like that, what else would you have to develop? So sort of different stages of work that you'd need to do for that. We've done a number of studies for our Earth Science program office. This is a Wordle for a study on global atmospheric composition. We really try to develop these science maps where we come up with a theme, science questions, what the figures of merit around those are, what the objectives would be, the main objectives, sort of a subset of those, who the stakeholders are, and what applications to that science would you have. This is a very high-level question to make sure when you're writing and justifying your science, you actually pull in as many people to be advocates and support your idea as possible. That's what this is about. Other times we do this evaluation where we say, is your science going to be, first of all, Oops, some of this got cut off. But number of science objectives. This is for the Venus In Situ Explorer mission. So the decadal survey said, if you're going to go to Venus and you're going to look at in situ measurements, you have these 6 objectives you need to achieve. And we started to take a look at things like an orbiter, a probe, a balloon, a lander, and how well they do those science. Are you just going to enhance the state of the art? Are you going to enable new science questions to be answered, new hypotheses to be found? Or are you going to have some kind of a breakthrough where basically after your mission we don't have to do anything else to understand that problem in the science? And where does this different architecture fit in that space, in that science space? Okay. So, improvements. We're working on building and improving our tools. We continue to work on new ways to do the idea capture, organization, and reference. We really like the idea that when a client comes in, they walk out of our sessions with some kind of product, or the next day they have some kind of a product from one of our sessions. Rapid mission design, the cost of the flight system, science traceability, all these different things are sort of going on in parallel. A lot of the core team members actually use their day a week to develop these tools for us. We're developing new methods. We have one pilot study every year where we try out something new, whether it's a new brainstorming technique, a new tool, a new way of having a conversation about something. We always try out new things. And we're always getting more people involved. We're up to about 500 people at JPL now that have participated in A-team studies, and the number just keeps growing. And so we're also trying to develop and train people on the A-frame, the method side especially, sort of build a network up of subject matter experts so that they're used to behaving and participating in our A-team studies, so we don't really have to train them. We're looking back at what we've done and trying to make sure we're keeping our clients and customers happy, so they like our products and we're making them better. And then we're trying to see what happens. After one of our studies, what happens to the idea? We suggested you go do this and hope that you propose this. Did you get it? Did what the A-team did actually help you get your funding for your next step? So we try to follow up with our clients and see how they're doing and see how things are going. Okay, so last slide. In summary, the A-team is one accessible and I'd say now proven. Before I took that, proven was a new word I got to add onto this chart. Way for JPL to explore the trade space and mature ideas onto concepts. It's a reliable and configurable process. We really do customize the study for each different thing that we come across. The A-team is really a collection of people, ideas, and objects that promote new connections and innovations at JPL. I didn't really talk about innovation much, but at our root is the idea that when you bring people together that haven't heard each other, or you bring ideas together that haven't been connected before, or you bring technologies in that haven't been seen by other people, that's where the innovation happens. Sure, every now and then you have this brilliant idea on your own, bright idea that no one's ever thought of before. But what we really see is effective is that trying to do this thing where we bring a lot of these people that don't really talk to each other early on. Most of the time, they drive, they get their concept, and they get it actually fairly mature before they bring in an expert that might tell them, no, that's not the way you'd want to do that, you should do it this way. Or don't even know what's possible to be done, and they just assume that this is the way you do it because that's what they saw in the last mission, when there might be a whole other way of doing it that's incredibly more cheaper, less mass, all those kind of good things. So we really try to promote innovation by building those new connections. In fact, one of the success criteria of our studies is really if one of those new connections has been made. Literally a person thing, managing the conversation. If we've made that kind of connection, then that's fantastic. And it really is available for use, even on campus. There's my contact information, or you can contact anybody else in the Foundry. The Section 312, which is the concurrent engineering group, that's the group that we pull most of our people from. So Robert knows very well what the A-team is and can help pull together a study as well. Okay, thank you.